So this particular RAG Accelerator includes three major uh, parts of AI systems nowadays, and that is RAG, MCP, and Agentic AI. RAG is your retrieval augmented generation kind of pipeline, and uh, enhancing the overall uh, knowledge of your LLM by providing it a context. So that is your RAG, and MCP server is nothing but giving access to the external entities for your agents so that you can enhance its capability, so that it can use these external tools to perform a real world action instead of just being having a generating text. And the third one, your agentic system, or the multi-agent systems, which have different agents working together to solve a single problem or to perform certain task. So these three major things encompasses the whole modern agentic AI or modern AI systems, for that matter. And with the RAG accelerator, we have tried to consolidate these three major ones and have this platform available for as a token of research that we have done here at Cloudaeon. So yeah, here we go. Okay, so before starting, just to let you guys know, to save time, we have pre-recorded the demo. I will be playing that video, and I'll take you guys through and explaining what is exactly happening at every step in this video. So yeah, let's begin. So this is our login screen of the RAG Accelerator application. Here we can see a credential needs to be given in terms of login to the system, and this is how you provide them. So yeah, this is where we get after successful login, and you can see on the left hand side we have various menu options available. On top bar, we can see on the left hand side there is a drop down for different workspaces, and on top right corner you can have a user settings. So before moving ahead with the actual usage of this application, let me explain you a quick setup that you need to do before starting the usage of this application. So you would need to set up a workspace to use it, and you can do that by going into this workspaces section, where you would create a new workspace and give the information such as the workspace name and description, and you can create one workspace for your use. So this is how it looks. These are the workspaces that we have already created, and you can also add users. You need to add users in terms of making it available for others. And this is how you create a user by giving the information such as the email ID and the related information. So yeah, apart from this, you need three very important connections. That is your LLM, vector database, and data source. And you can create LLM connection by going into this LLM setting. So we have changed the workspace to show you guys the already created LLM connections. So this is the pre-existing connections, and you can create a new one by going into this add connection and selecting the provider, the model, and uh, providing the information such as endpoint and API token. You can test it, and then you can add it to the system. And moving ahead, we have to create vector DB connection by going into vector DB settings. These are pre-created vector database connection. You can create a new one by going into this window and select provider. Similar to LLM, you have to again provide the information about that vector database. You can test the connection and add the new connection when the test connection is successful. So yeah, this is how you create a vector database connection. And the third one is data sources. So for data sources, you have to go to this particular screen and uh, enter the information such as what data source you want to create, the name of it, what type you want to create. So there are various types that you can create. So one of them being uh, a website. Other could be a different uh, storage accounts that you can use to create a data source connection. And here you also need to select the vector database where you would store the converted vectors into. So yeah, this is how you create a data source. And so after successfully creating a data source, this should trigger a pipeline which would convert all the data sources into readable format. I mean, readable as in readable to the LLMs, or useful with the LLMs, and that is vectors. So here you can see a status, a duration, when it was started, how much time it took, and you can also see the job runs inside the each job, and you can rerun the job with a new run if you think that you need to rerun this job in terms of getting a latest information from your data source. You can also schedule the job. So if you think that you need to rerun this job on a timely manner in automated way, so you can do that by going into this scheduling setting. So you can schedule this job for different types: daily, weekly, monthly, and you can also enter the time and the time zone. So this is very helpful in terms of having uh, these pipelines run in automated fashion instead of manually running it, so that if your data is changing frequently, and by frequently I mean daily, or a couple of days of week, or uh, one day a week, or any type of cron job, or the cron expression you can also use to schedule your job. You can also check the logs of every job by going into this section where you can view the log, and this gives you a detailed information about what exactly happened in this job or in this particular run, and what went well and what went wrong, so that you can correctly debug the run, and you can make the changes in your application to make it work as expected. So yeah, that is data ingestion pipeline. So now that we have all things ready, and now we can start using this application. And okay, so before actually starting the chat, let me tell you about uh, this particular use case. So bakery manual is a e-manual used by one of our customers to run their bakery operations. And the bakery manual is a online uh, website that is used by the bakery staff to ask, not particularly ask, but to look for the information related to their day-to-day bakery operations. And the problem that they were facing is, in terms of getting information, they had to manually go on the website and look for that information by going page by page if they don't know about the sections. And that was a tiresome task to do on a daily basis, and even in the rush hours they had to do the same thing in terms of getting the crucial information out of it. So the solution was definitely the RAG. So having all the information stored into the vector database, and using LLM's power to search through that information in semantic manner to get the correct information from that vector database. So that is what we have tried to solve with this in this use case. And for that we have this data source bakery manual, and this contains various data types like images, videos, PDFs, and a link to different data sources. So all this all these media types have been included, and uh, we have done a web scraping to convert this data into vectors and stored it into vector database. Uh, so let's start by asking some questions. I think we should have prepared some questions for the demo, and we should be pasting it anytime now. Yeah, there it is. So after asking this question, it will use its information from the vector database so that it can uh, get the most relevant information out of it. And that is what it have done, it seems. So this is the answer to the question, and it have used its knowledge from the vector database to answer this question. And you can tell that by looking at the citations at the end. So every answer comes with the citations, how that answer was generated, and all the facts that are coming from the vector database, and where exactly that information is coming from, the actual sources. We are showing it in the sources section, that is your citations. So once we open the citations, we would see different uh, media types. Here you can see images, you can see a link, and so on. So this gives you a confidence about your answer and how exactly it have been formed, so that you can open each one of these links and images, and you can see the actual facts where this answer has been generated from. So this again gives us a confidence about whether the LLMs are hallucinating or not. And here it seems that they are not, because we are generating the answer based on the strong facts and the sources that are actually there. So, okay. So with the sources, you can see one more thing at the end, and that is your feedback form. So here we can see this is the feedback form that is available below your sources. And if you think that particular answer is not right, or if you think that answer is right, you can give such feedback. Here for demo purpose, we are providing a negative feedback, and we are including that, or we are informing that to not include certain information in the answer. And now that if we ask the same question again, we would see it in action. So just because we have added this new information, it will use that information as a new context, and it will try to follow those instructions. So it seems that it have excluded that product ticketing uh, point from this answer. It have retained the other points, maybe representing in a different form, but in and all, the information that we asked it deliberately to not include is not included in the newer answer. So this particular feedback actually goes into the MLflow system. So we have included the MLflow UI in here. You can see all your experiments in it. You can go to your experiment, and you can look for the traces. So this is this is very helpful in terms of debugging the LLM requests. And here you can see the actual assessment that we have provided, or the feedback that we have provided, along with the rationale. So this is helpful in terms of debugging and knowing where exactly or how exactly the LLMs are responding to our queries. And that is how it helps in terms of traceability of the overall application. So now moving ahead, I think, let me, okay. Now let's talk about the MCP servers. This is the drop down that we use to add an MCP server to your chat, and this will help you enhance your overall chat experience, because now we are performing an external tools activity, And again, it's completely safe. You can use your own MCP servers, your own hosted MCP servers that are within your environment, and the complete process will be isolated to maintain the data privacy of the application. So this is how you select an MCP server. So this is Cloudaeon hosted MCP server, Outlook email MCP. And we have prepared some question to make use of this MCP server. And this is that question. So we are asking a question and we are asking it to send the answer to an email address. So what this will do is it will make use of the information from the MCP server, and that information is the details about what capabilities that MCP server has, what different tool it has, so that the overall system can make use of it to connect with the other entities of the whole system. And here it will use the email tool, that is the send email tool within the Outlook email MCP server, and it will try to send an email to that person based on the answer that we get. And the response here says clearly that it have successfully sent an email to this email ID. And let's see if we have received an email. Uh, so yeah, there it is. So we have received an email with the closing tasks for the day, and all the information that is being generated for that particular question. And if we go to these tools, let me just, yeah, so here you can see the tool shows us which exact tool has been used for performing this activity, and it says send email was the tool, and this was the message or the response from the tool itself. So yeah, that is about MCP server. So uh, with MCP server settings, you can create your own MCP servers. You can host them in your own environment, and then you can add those settings by going into the MCP server settings that you can see on the left-hand side menu. So it's similar to what we have with other settings. You can manage all the MCP server settings, and currently we are supporting two types of MCP servers. That is your already hosted MCP server. You can use any third-party MCP server as well, or you can create your own MCP servers, host them into one of the platforms such as uh, npm.js or PyPy, and you can use that build as a tool or as a whole MCP server in this application. So those are the two types of MCP servers that you can use with this application. Now moving ahead with agents. So agent, here you can manage the agent, you can create, you can edit, or you can delete the agents. Uh, this is how you create one, giving title, the description. Description is nothing but the instruction you want to give to agent, how it needs to perform and what activities it needs to do. Then we have these MCP servers. You can attach MCP servers also with your agents, and this is how you select them for each of your agent. So you can select multiple MCP servers as well to give access to various tools to your agents. So for this demonstration purpose, we have created these 4 agents. Uh, so by looking at them, you might have already understood that this is something for the data comparison, and yes, it is. So this demo will uh, show us how we can do the product comparison analysis or competitor analysis for a product. And these are the agents that we are going to use. So ideally we would drag and drop these into canvas, but for the demo purpose we have already created one, and that is what we are going to select from this drop down. So this is how it looks. So every agent here is connected to every other agent in the system, and here we can see all 4 agents being included in this whole system, where every agent will talk to each other in terms of achieving some task. So what exactly would happen is the request that is given by you would be going through this whole system, and the first the basic or the very first agent that we have set as a default agent would be the first to respond in here. So for example, web search would be the first or the default agent in this whole system, and we call it a swarm architecture, uh, the alternative name is network architecture. And you can start chatting with this whole system by clicking on the start chat button. uh, okay, and we can see the whole agent system on the left, and we can start asking questions to it. So the one question that we have prepared for this demo is to do product analysis or a competitor analysis for a certain product. So we should be able to see the prompt right now. So yeah, this is the prompt. So we are giving a URL and asking it to uh, do an analysis, competitor analysis, and create an Excel workbook and send it to this email ID. So this should be able to perform all these steps. And as we saw that the first default agent here is web search agent. So it should be able to start from that agent in terms of uh, starting giving out the answer about what exact steps it is performing. And that is exactly what we can see on the right hand side is the web search agent being executed, or it have started executing all these steps. And the first step that it have done is doing a web search, and it shows that it have found some information about the competitors. And now the agent is thinking about the next step, and it seems that it have transferred it to Excel generator agent, it seems, along with its input and what exactly it is passing on to the next agent. And it seems that it have passed on all the information that Excel generator agent will use to create the Excel workbook. And that is what is happening here. It is creating a worksheet, then uh, into that sheet it is adding all the information that it have gotten from previous agent, creating a table, formatting the ranges. So all these tools are within the Excel MCP server, which is being used by Excel generator agent, and it will try to perform as many tools as possible in terms of generating the final outcome that it can use it to pass it to next agent. And right here we can see that next agent is the email agent, and it have completed its execution now. And here we can see it have successfully sent an email of the Excel sheet it have generated. Let's see how we have received that email. So yeah, this is the email that we have received, and uh, here we can see an Excel is being attached, and that we can open and we can see what exact information we have got. So we go to this sheet, competitor products, and here we can see all the competitor uh, product list that we have got uh, as compared to the product that we have given to it. So here we can see information such as product name. The second column has specification, and we also have URL. So we can go to those URLs and we can see what products we have uh, got as a competitor analysis. So we can improve the performance of the agent by uh, changing the prompt or the changing the description that we have given to this agent. so that it can perform better as compared to the previous runs. So this overall gives us the uh, idea about how exactly the multi-agent system works with each other and how they perform in this RAG Accelerator application. So what happening in the background is each and every agent is talking to each other to achieve certain goal. And in this scenario, we have already given it a goal to perform the uh, whole task, such as finding the information and sending it to some email ID. So this is so all of this usage you can track by going into the usage dashboard menu. So this usage dashboard menu will give you information such as the cost, the time, and that too with very much of a detailed manner, and that also includes the success rate of your responses. What was the average response time for your uh, overall responses of chats? You can also get usage trends and usage by workspace, and you would also get detailed usage analytics such as cost distribution throughout various components like workspaces, chats, users, LLMs, and data sources. So you can make a better decision of which components to be continued to be used or which one you want to discard, and you would get a comprehensive uh, kind of a report by looking at this dashboard uh, about where exactly each and every spend went. So yeah, that covers the usage dashboard. Now, talking more about the overall improvements of this application that are in line, the first and foremost is the implementation of caching mechanism, and that will be done at two parts. First one would be done at vector database level, where a semantic search or a semantic caching would be implemented for semantic search, and that will help in terms of instead of going and converting each and every word again and again into vectors by using the vector LLMs, we would simply use the caching mechanism to do that, saving a lot of cost in terms of vectorization process. And other one is implementing caching at the actual uh, questioning level. So instead of always going to LLM to ask the question, we would have a certain safety window of time, and that could be 5 or 10 minutes. And within that time frame, if someone else asks the same question that previous user have asked, then we would reply with the same answer that we've got for the previous user. And that again, not just as simple as that, but we would perform a similarity search of the questions and the similarity between the data sources and the other factors that are included in the caching techniques. So yeah, that is the overall uh, RAG accelerator we have, and it has as we have saw, it has all three major components of the AI system: your RAG, MCP, and agentic system, uh, comprehensive of all the modern AI technologies. Thank you.